Bismillahirrahmanirrahim. Assalamu alaikum everyone. In this video we are going to solve a differential equation, first order differential equation, ordinary differential equation by series solution. We know that this differential equation the solution of this is an exponential function. Its solution is we know it, and we can solve it by separation of variable. Its solution is y is equal to some constant time ex. Now we want to apply a series and solve this differential equation and check that this solution can be obtained from the series solution as well. So we take a solution. Let y is equal to summation n from 0 to infinity an xn is a solution of equation 1. Let's say this is equation 1. Then it will satisfy this equation. So we will differentiate this y dash is equal to summation in from 1 to infinity n x n minus 1. So this is the derivative of y. We will put the y and our derivative of y in the given differential equation. Then the given differential equation takes this form. Y dash is y dash minus y, which is equal to 0, but I am putting the series. Y dash series is y summation n from 1 to infinity n x n minus 1 minus the series of y is summation from in 0 to infinity n xn, and this is equal to 0 because y dash minus y is equal to 0. Now we are rearranging the index here. We are putting n to be n plus 1 here. So in that case we will get n plus 1 is equal to 1 to infinity. So everywhere we replace n as n plus 1. So n will goes to n plus 1, n will goes to n plus 1, and x power n plus 1 minus 1 minus, and leave this one as it is. So you see this one is cancelled with this one. So what this is called shifting. This is now starting in from 0 to infinity n plus 1 n plus 1 xn minus summation n from 0 to infinity an xn. So this shifting, what this shifting did, you see the power of x become equal. Now we can take out the power and also the summation sign, because the summation sign starting from the same 0. So taking this common, n from 0 to infinity, and the coefficient is n plus 1, an plus 1 minus an, and I'm taking xn as common. Now comparing the coefficient of xn on both sides, we have comparing coefficient of xn on both sides. We have n plus 1 into n, a n plus 1 minus a n equal to 0, and this will give me a n plus 1 is equal to a n divided by n plus 1. We call this recursion relation. This equation define all the constant coefficient of the series, and you see n start from 0, 1, 2 up to so on. So I will put one by one here and will find these constant. So you see, when I put n0, I will get a1, which will be equal to a naught over 1, and I am put it, then a n is equal to 1, so that will be a2 is equal to a1 by 2. Putting a1 from here, that is a naught over 1 and into 2, so that is equal to a naught by 2 pictorial. Similarly, we can find a3, that will be equal to a2 by 3. Putting a2, I will get a naught by 3 pictorial. That implies a n should be a naught over n pictorial. Now we take the solution as a series y is equal to summation n from 0 to infinity a n x n, which can be written a naught plus a1x, a2x square, a3x cube, a4x4 up to so on, and we find all the constant in term of a naught. So this y is now y is equal to a naught is a naught, but a1 is a naught by 1 pictorial x. What is a2? That is a naught by 2 pictorial x square. What is a3? That is a naught by 3 pictorial. What and x3? What is a4? That is a naught by 4 pictorial x4, and so on. What is a n? That is a naught by n pictorial xn. And this is continue because n goes to infinity. So what is this? This is simply y is equal to, I am taking a naught the common, and this is 1 plus x square by 2 pictorial. Here is 1 pictorial, and x cube by 3 pictorial up to so on, x n by n pictorial up to so on. And we know that what is this, what this series is. This is a naught, a constant time exponential of x, and this is the same solution we know. So this implies that the series solution work well for the ordinary point. We take ordinary point here x 0 because the given differential equation is defined everywhere, its solution defined everywhere. So I take ordinary point x naught and take the series this one, this series solution, and find what is the main job here to find a n. So we find a n, put here, and we see that this solution is exactly obtained by the series solution. So this means that the series solution work well. Thank you.